Hello, 7th grade. This is Lesson 2. Our objective is to understand and be able to identify properties of operations, and then I guess we could also add be able to use those. So let's just go ahead and get these properties out in the air so that we understand them and know how to use them. And the first one is called the inverse property, and that's just really thinking about what operations kind of undo each other or are opposites of each other. And so addition and subtraction are what we call inverse operations, because if you were to add 2 and subtract 2, that would kind of give you nothing, right? Add 2 minus 2, maybe if you said 5 plus 2 minus 2, that just give you 5, it gives you back to the same number. Same thing with multiplication. If you did 5 times 2, that gives you 10, and then if you divide that by 2, it'd give you back to 5. So those multiplication and division are opposite operations, or what we call inverse operations. Next thing we're talking about is the commutative property. Whenever I hear the word commutative, I think about commute, like a commute to work. Maybe you've heard that before. So like whenever I come to work, I pass an Arby's, then a Whataburger, then Tally's. But as I go home, I pass Tally's, then the Whataburger, then Arby's. So it's the same thing, but in the opposite order. So think about for commutative property, 2 plus 3, this is for addition, that's the same thing as 3 plus 2. Notice, see, on the way to work I pass 2 and then 3, but on the way back I pass 3 and then 2. And notice this is of addition, so that's why we're working with addition. But the same thing also holds true with multiplication, meaning 2 times 3 is the same thing as 3 times 2. All right, the identity property, there's a little bit different. It's a little bit different for addition versus multiplication. The identity property of addition says if you take any number you want, I'll call that number A. And if you add 0 to that, you're going to get back to the same number, A. It kind of makes sense, like if you said 7 plus 0, you still get 7. Or 9 plus 0, you still get 9. And so this 0 here is what we call the additive identity. The additive identity. Please use that word whenever you go home tonight and your parents ask you what you learned. Say, oh, we talked about the additive and multiplicative identities. They'll make you sound really smart, and they'll be really impressed with the school. So make sure you use those words. For the multiplicative identity, that's number is 1. So think about if you took any number, I'll call this one B, except for I didn't want to use a highlighter anymore. If I took any number B, let's say, and I multiplied it by 1, I still get the same number, B. Kind of like 2 times 1 is just 2, or 5 times 1 is still just 2. So again, that what we call the multiplicative identity is 1. So for multiplication, the identity is 1. For addition, the identity is 0, because you get back to that same thing that you started with. The last property that we need to learn about today is what we call the associative property. And think about kind of who you associate with, who you hang out with, say at the lunch table. The associative property, if we're going to use letters, would be like A plus B plus C. And notice if I did the same thing on the other side, A plus B plus C, you'd be like, oh yeah, those are the same. But the associative property says that if you associate these two, meaning that if you added the first two, A and B first, you get the same thing as if you added the second 2 first. Let's kind of illustrate that with like 1 plus 2 plus 3. 1 plus 2 plus 3. Over here, 1 plus 2 is 3, so I end up with 3 plus 3, which would give me 6. On the right-hand side, if I added the 2 and the 3 first, let's say 1 plus 2 plus 3 is 5. And notice 1 plus 5 is 6. So I get the same thing either way. So that's the associative property. Because here the A and the B are hanging out. Here the B and the C are hanging out. So the B is choosing to associate with different people. Same thing again holds true for multiplication. So if we did A times B times C, that's the same thing as A times B times C. Sorry, my handwriting got a little bit crazy there. Same thing here. 1 times 2 times 3. If I multiplied those two first, I'd get 2. Times 3, I'd get 6. Over here, this would be 1 times, if I did 2 times 3 first, that'd be the same thing as 1 times 6, which again just gives me 6. So either way, it comes out to be the same. Alright, so which number is known as the additive identity? Which number is the multiplicative identity? So this is something we just talked about, the additive identity. So the additive identity, 0. Because if I take 0 and add it to any number, I get back to that same number. The multiplicative identity is 1, because if I take 1 and multiply it by any number, then I'll get back to that same number. B is which operation is the inverse of multiplication? We know that what does multiplication is division. Use the letters X, Y, and Z to write an equation that illustrates the associative property of addition, Then write an example using counting numbers of your choice. So I'm going to bring that down here. This is going to be part C here. I'm going to say X, it says of addition, so I'm going to say X plus Y plus Z. Since it's the associative, I'm going to say those two are associating together. That's going to be the same thing as saying X plus Y plus Z, with those two associating together. So that's using the X, Y, and Z. It says then, so now I'm going to write an example using counting numbers. So I'm going to use 2, 4, and 6. 2 plus 4 plus 6. The same thing as 2 plus 4 plus 6. It's going to be 6 plus 6. The same thing as 2 plus 10. So 12 is equal to 12. And there I've showed that those two are the same. D says name the property we can use to find the missing number in this equation. So I'm looking at this and it says 5 times something is the same thing as 8 times 5. Notice I have a 5 on either one, but the order is changing, right? Here the 5 came first, but here the 5 came second. If these are equal, that means this one must also be 8, and that is what we call the commutative property of multiplication because they're multiplying. Add, subtract, multiply, or divide as needed to simplify each expression. Remember to work within the parentheses first. So let's see here. This first one, 5 plus 4 is going to be 9. Plus 3, 9 plus 3 is going to give me 12. F is going to be 5 plus 4 plus 3 is going to be 7. It's going to give me 12. That's illustrating the associative property there. 10 minus 5 is going to be 5 minus 3 is going to give me 2. This is going to be 10 minus 5 minus 3 is 2, so this is going to give me 8. I forgot to box this one in over here. 6 times 2 is 12 times 5. That's going to give me 60. Here this is going to give me 6 times 2 times 5. I forgot to box in again. 2 times 5 is 10. So 6 times 10 comes out to be 60. 12 divided by 6 is 2. 2 divided by 2 gives me 1. Over here, this is going to give me 12 divided by 6 divided by 2 is 3. So 12 divided by 3 gives me 4. Man, I'm forgetting to box those in. Alright, so this kind of helps us illustrate that addition and multiplication, notice those answers came out to be the same. So those do work for addition and multiplication. However, notice with subtraction and division, we're getting different answers. This one got 2, this one got 8, this one got 1, this one got 4. So those properties don't necessarily apply to subtraction and to division, but just to multiplication and addition. If you haven't noticed it already, your homework is down here in the corner. You're going to start on page 18. You're going to do 1 through 30 all. Good luck, guys.